So here's a car collision problem. We've got this car with this much mass going this fast. It rear ends a smaller car with this much mass. It's already going 16 meters per second in the same direction. The two cars stick together after the collision. How fast does the wreckage move immediately after the collision? So there's a classic collision problem where you use conservation of momentum. So let's set this problem up, given. Okay, so here's our bigger car. I'll draw like an SUV or a van or something. Okay, and we'll call it car A, just like the book does, car A. And it has, we know what MA is. Okay, and it's going 28 meters per second. So I'm going to call that VA initial. This is the initial velocity for car A. Now the book puts a 1 right there. I don't like using ones, so call it initial. And it's going 28 meters per second. Now here's our little car, which we'll call car B, and the mass of B is 875 kilograms, and the initial velocity for car B is 16 meters per second. Okay, and so what we want to find is, well, here are the two cars after the collision, just after the collision. Here's our big car. It's got kind of smushed in a little bit. And here's our smaller car. So here's A and B, but they're moving off together. They've stuck together. They have, in other words, their final velocity is the same. So I'll just call it VF. And they've stuck together and they're moving, and this is just after the collision. So let's solve it. Now the way you solve this problem is you say, look, during a collision, the amount of momentum in your system, and this is my system, these two objects right here, the amount of momentum does not change. Yes, car A gets its momentum changed, and car B gets its momentum changed. But the change in momentum of A is equal and opposite to the change in momentum of B. So when you add them together, you get 0 overall change. So the initial momentum of my system is equal to the final momentum of my system. This is your basic equation for collision problems. Then you ask yourself, okay, what is the initial momentum of my system? Well, car A is moving, and momentum is mass times velocity. So it's MA times VA initial. That's the momentum of car A, plus the momentum of car B. So that's MB, VB initial. So this is the initial momentum of car B. You add them together, that's your total initial momentum. That's going to be equal to my final momentum. Well, let's look at this after the collision. What's my total mass here? Okay, well, what's the mass of my final object? Well, it's both objects are together. So what do I have to do to the mass? I have to add the mass of A and B, because they're moving off together, times their final velocity. So now I've got everything I need to solve the problem. I know what the masses are, that's given, and I know what the initial velocities are. This is the only unknown. So you solve for it. It's MA, the mass of car A, and it's moving in a positive direction, so it's plus the mass of car B, right here, times its given initial velocity. And then to solve for this, I divide by the total mass, which is 2,275 kilograms plus 875 kilograms. Now you just get out a calculator and you plug all that in. And I'm not going to take the time to do it because the bell's about to ring. But what you get is the final velocity of this system. It's 25. When you round it off, it's 25 meters per second. Now, this is a very powerful thing to be able to do. If you know the initial velocities and the masses of two objects that come together and stick together afterwards, you can figure out what their final velocity is after that happens. Okay? Like two spacecraft docking in space. Or two railroad cars connecting together, coming together and connecting together. But the main thing is this, right here. This is the big idea that this problem is trying to teach you. That is all.